This is Mrs. O'Neill for Chapter 9, Section 1, Part 3, Polyatomic Ions. So pause the video, read as you write, and then play to hear my words. So hopefully this makes sense. Poly means many, atomic means atoms, and an ion means it has a charge. So that definition should make sense. Polyatomic ion is many atoms with a charge. Now if you look at this list here, hopefully you notice that most of them end in 8 or 8. So that's going to be a clue when you're looking at the chemical formula for a compound. You're going to go, oh, it ends in 8. So that second part of the compound must be a polyatomic ion. So now you're going to know where to look on your reference sheet. However, I do want to bring to your attention a few things. The first thing I want to bring to your attention is 2 of them end in "ide." Now remember, your non-metals, when they change into anions, their name changes to the IDE ending. So we want to make sure that not all IDE endings are going to be just that non-metal. So keep in mind, cyanide and hydroxide are going to be polyatomic ions. And again, you're going to see these and you're going to do practice problems, so hopefully you'll just kind of click by the time the test comes around. And there's one other polyatomic ion I want you to notice. Ammonium is going to be the only polyatomic ion that you need to know that has a positive charge. There are a few others, but this is the only one you're going to need to know. Okay, the other thing I want to bring to your attention is even though it's many atoms with a charge, we're going to kind of treat it as one component of that compound, whether it be the first part that's always positive in a compound or the second part that's always negative in a compound. Remember that a compound only ever has 2 parts. It has your positive part first and your second part is always negative. So we're going to treat it as a whole component, or that whole part of the compound. And I'm going to show you what I mean by doing some practice and dealing with these. So again, on your reference periodic table at the end of your packet, here on the top is your list of polyatomic ions. So again, you might want to do yourself a favor. First of all, look it over. Notice how they're all in alphabetical order according to name, okay, according to name, not according to the formula. You might want to highlight or understand ammonia is the only one that's +1, and you might want to highlight or take note of the cyanide, which is here, and hydroxide, which is here. It's the only 2 that end in IDE. And this acetate guy, if you're wondering about him, we'll talk about him a little later as well. So pause the video, read that these are the models, and can you come up with an answer for interpreting diagrams? Hopefully this makes sense, that the only ammonium ion, or the one that you need to know, is the only one that's positive. And I thought that this was nice because these show you the structure of the main polyatomic ions you're going to need to know. These 4 are probably, again, you're going to see over and over and deal with over and over, that it's going to come second nature. So I'm not asking you to memorize anything that's on that ion sheet. However, it's going to be beneficial for you to either know what we're looking for, where it is on the chart, or just know it because now you know it, you've used it so often, and now you've memorized it. So let's figure out or understand how these polyatomic ions work in compounds. So this is going to be another spot where I'm going to say, you know what, listen to my spiel first, and then I'm going to tell you when to pause the video and copy it in your notes. So you should still have that chart out though, because that's going to be very helpful to find the parts of the compounds, and the more you see it, the more you use it, the more secondhand it's going to be. So let's look at this guy, sodium sulfate. Can you pause the video, find sodium and its charge, and find sulfate and its charge? Hopefully you paused, and sodium's pretty easy now. You probably know that that's Na+1, but sulfate, ooh, ATE, so it's got to be one of those polyatomic ions, and it is, SO4 -2. Okay, so what do I mean by a general formula? Okay, well, I'm going to treat my first part of the compound as my X component and my second part as my Y component. Now, look at those charge numbers. What are we going to do with those charge numbers since they're different? We're going to crisscross them. So the general formula is going to be 2 x's with 1 y. Hopefully that makes sense. I'm just looking at the 2 parts and I'm trying to figure out how many of each part do I need according to that charge number. Okay, now let's plug in what was for x and what was for y. Well, it would be that, Na2, because there's 2 first part of my compounds, and SO4, 1, even though it's understood. Now, what do I mean by a true formula? In this case, my possible and my true formula are the same. It's not going to always be that way, so I'll tell you when we get there and get you to understand what I mean by that. So pause the video now and write these in your notes. I think there's a nice little chart there. Okay, so can you pause the video and find magnesium? Because you should already know what sulfate is from the last one. So hopefully you found magnesium in group 2's got a +2 charge. Sulfate we already know. All right, what's that general formula going to be? Well, my x component and my y component. Knowing my charge numbers are the same, we're going to cross them out. So I'm just going to have an x and a y. Now, again, put in what x and y represented. In this case, MgSO4. And again, this case, the true formula is going to be the same as the possible formula. All right, pause and write that in. So, you know what magnesium is. Can you find nitrate? Ooh, ATE, polyatomic ion. So we have magnesium and we now have nitrate. All right, what's my general formula? Well, x, y. My charge numbers are different, so we're going to crisscross them. And so now I'm going to have x, y, 2, right? 1 x component and 2 y components. Let's look at this possible formula. If I rewrite everything the way I'm used to, I would have MgNO32. Oh, wow, right? This is telling me I have 1 Mg, 1 nitrogen, and 32 oxygens. As of now, guys, I don't know about you, but we haven't seen 32 oxygens in any chemical formula. Well, what does that tell you? Remember in the beginning of the chapter, I read that article to you, that information about sodium and chlorine, and how it's really important to make sure we have the correct ratio of our elements in the compound. So, what do you think we can do to make sure people understand that we only need 2 nitrate components? Did parentheses come to mind? So now with the use of parentheses, we can have 1 positive part and 2 negative parts, and the parentheses are telling me that I need 2 nitrate polyatomic ions in my compound. All right, we're going to do a bunch more, so don't you worry. Pause, write this in. All right, let's look at aluminum nitrate. So you should know what nitrate is. Find aluminum. Hopefully you paused and found aluminum to be +3, nitrate to be -1. All right, let's come up with that general formula. X, Y, our charge numbers are different, so crisscross. Our general formula is going to be X, Y, 3. So I have 1 X component and 3 Y components. So, ooh, again, doesn't that look funny? I have 1 aluminum, 1 nitrogen, and 33 oxygens. Again, if you were a doctor and you needed to prescribe a particular medicine to somebody, you need to make sure you're prescribing the correct chemical formula. So what can we put in there to make sure people understand we do not have 33 oxygens in this chemical compound? We have 3 nitrate polyatomic ions. Yes, you're going to need those parentheses again. So again, see how it kind of gets confusing, but the more you see it and the more we're writing things down, the more practice we have, the easier it's going to be. It's going to become second nature when to use these parentheses. All right, pause and copy those down. Next one, calcium phosphate. Can you come up with the parts now on your own? Hopefully you paused and came up with these 2. Why don't you pause now and see if you can come up with the general formula on your own? Hopefully you paused and you thought of X, Y. The charge numbers are different, so crisscross. And we came up with X3, Y2. So 3 positive parts and 2 Y parts. So what could be the possible formula? So if we do things as we've been doing them, I would have 3 X's and I would have 2 Y's. But because of that polyatomic ion, it really looks like we have 42 oxygens in this compound. That's a little ridiculous. So again, what would that true formula look like? Pause and think about it. Hopefully you thought about it, and again, you're using those parentheses. Pause the video and get these all in that chart in your notes. All right, here's another one. I know it seems redundant or that we're doing the same thing over and over again, but this is a difficult chapter for most students, and the more you see it, the more it makes sense and the easier it becomes. All right, so potassium chlorate. Again, potassium is probably a metal, hint, hint, because these are ionic compounds. And since I see chlorate, I'm trying to find a polyatomic ion, so look in that section. All right. Hopefully you paused, you came up with the two parts. Can you pause and come up with the general formula? Here's my X, here's my Y. I have 1 and 1. My charge numbers are the same, so those just go away, and I rewrite the parts. So what's going to be my possible formula? Rewrite the X and the Y, and in this case again, the true formula is going to be the same. All right, pause and get those in your notes. Next one, lithium, metal, and sulfite. Ooh, ITE. Make sure that you are finding the correct polyatomic ion. Hopefully you found those two things. So can you pause and come up with the general formula now? X, Y. Charge numbers are different. Cross. So we have X2Y. Ooh, so Li2SO3. Hopefully that makes sense. And you know what? That looks good. So we're going to keep the possible formula and the true formula the same. All right, pause and get those in your notes. So how about ammonium carbonite? Ooh, a little tricky here. Now I have two, hint, 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 two polyatomic ions. So do you think you can come up with the parts, the general formula, the possible, and the true formula without kind of clicking through ahead? Hopefully you paused and tried to do everything. So here's my two parts. Here's my X, Y. I need to crisscross my charge numbers because they're different. So now I have two X's and one Y. So my possible formula looks a little goofy. Again, 42 hydrogens is a little ridiculous. So what are you going to use instead? You're going to use those parentheses to say, oh, in this formula of ammonium carbonite, you really have two ammonium polyatomic ions and one carbonite polyatomic ion. And remember, make sure you use your capitals and littles correctly, okay? So in other words, I'm saying to you, make sure that your O for carbonite is a capital O, because if it's a little o, it might look like cobalt, okay? So make sure that your capital letters are capitalized and your lower cases are lower. All right, now pause and make sure you get that in your notes. All right, zinc hypochlorite. Whoa, can you find zinc and can you find hypochlorite? Hopefully you paused and maybe even came up with the general formula, the possible, and the true. So here's our parts. Here's our XY. The charge numbers are different, so crisscross. General formula, possible formula. I'm going to pause here, and I'm going to say just kind of look over that. Doesn't something look strange? At a first glance, ladies and gentlemen, that looks fine to me. However, notice your polyatomic ion is ClO with no oxygens. So this chemical name would be zinc chlorite, not hypochlorite. So we still need those parentheses around hypochlorite, even though it doesn't have a number with the polyatomic ion. Again, see how it gets tricky? Because there's all these little minute little rules or little exceptions to the rules. So even though this looks okay, it's not okay. It would be a totally different compound. All right, get those in your notes. All right, I think this might be the second or the last one. Nickel 3 hydroxide. Can you come up with these answers? Hopefully by now you got the parts. You notice that it's an X and a Y. You notice that the charge numbers are different, so crisscross. You got the general formula, you got the possible formula. Uh-oh, it's another one of those where it does look okay, but this tells me I have 3 hydrogens instead of 3 hydroxides. So there is going to be a trick to that. All right, pause and make sure to get those in. All right, we'll see you in class for questions.